Alright, CNT120, we're on Chapter 4, we're on the section on IP, Internet Protocol. This is the main protocol that's operating here at the Internet or network layer. Remember, the IP addressing, the IP address, that is used to route the traffic to the correct network. My network as opposed to your network. The York network of hack as opposed to the Gettysburg network of hack. Okay, that's what your IP protocol is all about. How the data should get, basically where the data gets delivered to, source and destination IP address is in that IP header. IP itself is unreliable. It's connectionless. You just put the address on, all the devices read it, make a decision, move it on. Very similar to, putting an address on a letter and mailing it. There is no double check or anything on that. It's just every individual picks that up, reads that, makes a decision to go into this bin as opposed to that bin kind of thing. Any sort of reliability is going to get handled by upper layer protocol TCP if that is needed. Remember, there's two types, IP4, IP6. IP4 32-bit address, IP6 128-bit address. Their headers are similar, but at the same time they are different. So let's take a look at both of these. Here's our IP header. Again, lots of fields here, lots of fields. As we look down through, first field we'll see is the version, and that'll let us know whether it's version 4 or version 6. IHL, initial header length. This lets us know again where the header ends and the data begins. The diffserv, this is a field for dealing with priority or traffic of that nature, where this is voice or video, this needs to go first. This is, delay sensitive email, that can go second kind of deal. That field gets used for your priority or quality of service. Total length lets us know the whole packet size. So when this ends, we get to this bits, we know this packet ends and the next one starts, if you will. In here, these fields go together. If for any reason this IP packet needs to be fragmented, the identifier gets used to say these three fragments go back together, please. And the flags let you know if it's fragmented, and the frag offset lets you know, is this the first chunk, middle chunk, end chunk of these fragments, so it can put it back together correctly. TTL, time to live, this is basically like an expiration date, if you will. Every time this IP packet goes through a router, for example, that decreases by 1. When that reaches 0, this IP packet is considered undeliverable. It keeps looping the network, so it is basically thrown out at that point. That gets set by your network traffic, your network devices. Protocol lets us know what protocol is inside. So whether it be TCP or ICMP or something like that, it lets us know what is enclosed inside. Header checksum is just that. It's kind of like before I mail my letter, I verify everything is correct. The header checksum is just that. It does a calculation, puts that number in there, the receiving end does the same calculation. If the number is the same, then we know the header data should be okay. Then we're into the source IP, who's sending, receiving IP, destination IP is where it's going. And then we finally have our data down here. And here's our header fields kind of all broken out for you. All right, this is a sample IP header. We're going to look at a real one here in a minute. And then this is the breakdown of that. So I am going to show you an IP header in a minute, but let's go through IP version 6 and ICMP, because I'm going to do a ping for both of these, and we'll look at all those header fields at the same time. So we're going to keep going for right now. IP6, 128-bit address. Here's our header fields. As you see, there's a few less. It's the same ideas, but it's a few less. Version field, again, lets us know version 4, version 6. Traffic class, this is like your diff services field in IP4. This is for quality of service, as well as a type of service for the type of data it is. Voice or video would get priority. Delay sensitive email files can go second, if you will. Flow label lets us know that these couple packets are part of the same maybe audio or video stream, so it can't handle them together, if you will. Payload length, letting you know how much is in here, how basically the length of this thing, so we know where it ends and the next one begins, the next packet begins. The next header lets us know what protocol is inside, TCP, ICMP, whatever it happens to be. And then hop limit, which is kind of like your TTL field in IP4. After so many, this keeps decreasing. When it gets to 0, packet is considered, it keeps looping the network, if you will, and it's considered expired, and it gets rid of it. We have the source IP address, a lot more space because it's a 128-bit address, and destination IP address, again, a lot more space because it's a 128-bit address. And here's the breakdown of the fields, and then a sample IP6 header and the breakdown of its fields. Again, we'll look at that momentarily. Well, we're going to use ICMP to do it, so let's take a look at ICMP, and then we'll generate some ICMP traffic and then look at all of these header fields. Well, ICMP also operates at the internet layer, Internet Control Message Protocol. It is here for just that, messages about delivering of data, whether it got delivered or it did not get delivered. So when we do something like a ping and we get reply from, that's a successful note. We know it got there. If we do a ping and it says destination unreachable, that's an error message. That lets us know it did not get there. So ICMP is the one that's giving us these messages when we're doing pings, when we're doing traces, those sorts of things. So ping is part of ICMP, giving us these messages about delivered or not delivered. And there literally is ICMP for version 4 and ICMP for version 6. Here, type field, type of ICMP message it is, header checksum, and then the contents are going to vary depending on what the type of message that it is. Okay, so now let's take a look at, I'm going to look at ICMP version 4 and version 6. So let me pause, I'll adjust the screen, and we'll get some captures and some pings going. All right, so here was our capture from the last time. We're going to clear this out. I'm going to start a new capture. I'm not going to continue with anything there. I'm going to pull up my command prompt, and let me clear out what's here. And let's do a ping to, and I'll do a ping-4, so I'm going to go to, I'll pick on hack.edu. Okay, it's going to give me an error message, which is fine. It's going to time out. That's all right. We still can see the data we need to. And then we're going to issue a new ping. We'll do a ping-6. The hack website is configured to not respond to these ping requests. So let's do a ping-6 now. And we'll go to google.com. And now we should get some successful replies. So we got some error messages for the 4, and we got some successful replies with 6. So up here, let's stop our capture. And let's put in ICMP version 4. Actually, you can just do ICMP. That'll be version 4 by default. And you can do it. There we go. So here is those error messages we got, and it's even lighting up yellow saying, hey, it was not no response seen, which is fine. Here's us trying to ping the hack.edu website. If I take a look at the ICMP header, this was an echo request, and the next one coming back would be another reply if we were to look at that one, if you will, but there was no reply. So these are just simply requests going to there saying, hey, are you there? And we got no response back. So in real life, that could be one of two things. Either that the server is off, or in this case, the server is programmed to not respond to us. So we're getting an error message. Well, let's look at the IP header now. There we go. We got a bunch of header fields. So if we take a look through the first header field, version 4, letting us know it's IP version 4. Header length, letting us know where the header ends and the data begins. Here's your diff services fields. There was no priority or anything kicked in, but this is where that would be. Total length, and in other words, this packet is this long, and then any bits after that would be the next packet or next chunk of data. Here's the ID field. If this were to have gotten fragmented, this ID would allow you to take all those fragments and put them back together. All the fragments that are labeled, what is it, 47 and 160, all those could get put back together. Here's the flags field letting us know if it is fragmented and whether it is if there is more fragments or where it is. And then right here is the frag offset. If we have a couple, let's say there's 3 fragments, it would let us know 0 for beginning, 52 for middle, and 132 for the end kind of thing. There's the TTL, and it lets us know the protocol inside is ICMP. And then here's the source IP, my IP, and then destination IP of hack.edu. So there's our ICMP version 4, but also our IP version 4 header fields. Well, let's research and do version 6 now. And this will be us pinging google.com, and we want to look for the request replies. So here we did a request and we actually did get a reply back. So we'll look at the request. Here's the ICMP version 6. Here's the echo request. And if I click the next one in line, I'll get the reply, and here's the reply coming back. And the actual data, here's the data that I actually sent for that ping request and reply. So here we're getting a checksum, yeah, good, okay, and we're basically getting request reply. So we're getting a reply back from. Well, let's look at the IP version 6 header. A little bit smaller. First header field version 6, letting us know it's IP version 6. Here's your traffic class. This would be here for quality of service priority, if you will. Here's the flow label. So if we have a bunch of packets that are part of an audio or video stream, the flow label these would be similar, so that, hey, they're all part of the same conversation. Payload length, next header ICMP version 6, which it is. Hop limit 118, and then the source address and the destination address. So the source address, let's see which one we were going here. This was the reply. So the request here, the source should be my machine, and the destination should be the Google website there. So here is our IP version 6 header as we were looking at ICMP version 6.